Welcome to my video on producer-consumer problem. What is a producer-consumer problem? So a producer-consumer problem is a classical synchronization problem. It involves two processes, producer process, consumer process, and they both use a shared common buffer. So what is a producer process? So producer process, it produces data or items, places items into the shared buffer, and it must wait if the buffer is full. Shared buffer is a common memory area which has limited size. It is accessed by both producer and consumer, and it needs mutual exclusion. And now what is a consumer process? So a consumer consumes data or items, removes item from the shared buffer, and it must wait if the buffer is empty. Thus, a producer-consumer problem is a synchronization problem where processes communicate using a bounded buffer and requires coordination to avoid race condition. So, producer should not add data to a full buffer, consumer should not remove data from an empty buffer, and simultaneous access must be avoided. So, what is the need for synchronization? So, synchronization is required to avoid race condition, to ensure data consistency, and to control process execution order. We will take one simple analogy to understand a producer-consumer problem. So the scenario is shown in the image where we can see a cook is a producer, consumer is represented by the waiter, and buffer is the serving counter with a fixed size of 5 plates. So here how it works. So technically a producer, that is cook, produces items, the food plates. Each produced item is placed into the shared buffer, that is the serving counter. And the waiter, who is acting like a consumer, removes item from the buffer to serve the customer. And we should note here that the buffer has a limited capacity of 5 plates. Here the constraint is if the buffer is full, the producer must wait. If the buffer is empty, the consumer must wait, and only one process can access the buffer at a time. So again, here the need for synchronization arises. Why? To avoid the producer from overwriting data when the buffer is full, to prevent the consumer from reading invalid data when the buffer is empty, and to ensure the mutual exclusion while accessing the shared buffer. So we'll take one more example where a producer process is the keyboard input process, consumer process is the text editor or the display process, and the shared resource is the input buffer, that is the main memory. And we will assume the buffer size to be fixed, that is 10 characters. So how it works? So the producer process reads characters from the keyboard. Each character is stored in the input buffer. The consumer process reads characters from the buffer and displays them on the screen, and the buffer can store limited characters only. So the constraint is if the buffer is full, the producer process waits. If the buffer is empty, the consumer process waits, and both processes access the buffer through the critical section. So the synchronization is required to prevent the buffer overflow, to prevent buffer underflow, and to ensure the mutual exclusion while accessing the shared memory. So there should be some mechanism for the synchronization because we know synchronization is required. So what is the mechanism used? So the mechanism used is a semaphores. What that is? So a semaphore is a synchronization tool used in the operating systems to control the access to shared resources by multiple processes or threads. So a semaphore is basically an integer variable used to manage process synchronization and ensure mutual exclusion in the concurrent systems. So there are three semaphores. The first one is the mutex, which allows only one person to access the counter at a time in case of our analogy, applied to analogy. Empty semaphore counts how many empty spaces are on the counter, whereas the full semaphores counts how many plates are ready on the counter. So we can understand that semaphore is just a variable that helps processes coordinate with each other and avoid conflicts when using the shared resources. So why to use semaphores? To prevent two processes from accessing the same resource at the same time, that is mutual exclusion. To manage producer consumer, reader writer and other synchronization problems, and to avoid race condition, deadlocks and data inconsistency. So basically there are two types of semaphores. The first type is the binary semaphore, which has only two values, 0 or 1. It works like a lock and it is used for mutual exclusion. Second is the counting semaphores. So values can be from 0, 1 to up till n, used to count available resources. Example is the empty slots, number of items, number of threads allowed, etc. Just an example to understand. So suppose if a student wants to enter a computer lab with 20 computers, then a counting semaphore starts at 20. Each student takes one computer and the semaphore decreases. When no computers are available, the next student must wait. When the student leaves, the semaphore increases. So, a producer consumer problem is a classical multiprocess synchronization problem in operating system, also known as the bounded buffer problem. It describes a scenario where multiple processes must share a limited resources without conflict. The problem involves a producer that creates data items and places them in a shared fixed size buffer, and a consumer that retrieves and uses these items. The main challenge of this problem is to ensure producer does not add item to the full buffer. Means if the buffer is at capacity, the producer must wait. Second, a consumer does not attempt to remove items from an empty buffer. Means if the buffer is empty, the consumer must wait. And third is the mutual exclusion. Both processes should not access and modify the shared buffer at same time, which could cause data inconsistency or corruption. So we know the solution. The solution is using a semaphores. So a common solution for the producer consumer problem uses semaphores, which are integer based signaling mechanism. The solution requires three semaphores. The first one is the mutex, that is a binary semaphores. It ensures mutual exclusion, meaning only one process, that is producer or consumer, can access the critical section, that is the shared buffer, at a time. It is typically initialized to 1. Second is empty, that is counting semaphore. Tracks the number of empty slots available in the buffer and it is initialized to the maximum size of the buffer. Third is the full, that tracks the number of full slots in the buffer and it is initialized to 0. The wait operation decrements a semaphore value and the signal increments it. So, this is just a summary table that will give you more idea about the semaphores. The wait and the signal operation are used on these semaphores. Wait decreases the semaphore value S by 1. If the new value is negative, the process is blocked. And signal increases the semaphore value S by 1. And if the new value is not negative, it unblocks the waiting process. So the benefits of using semaphore solution is: first, race condition. So mutual exclusion ensures only one process accesses the shared buffer at a time. Second, buffer overflow. The empty semaphores prevents the producer from adding items when the buffer is full. Buffer underflow. The full semaphore prevents the consumer from removing items when the buffer is empty. And busy waiting is the process that needs to wait. Either the producer or consumer are put to sleep instead of wasting CPU cycles in the busy wait loop. Thank you.